So we have this canonical LR0 collection and the parsing table ready with us. So now let us see an example for tracing the input string using this parsing table, and you will find whether that that string can be accepted or not using this for this particular grammar. Okay, just recollect that you have all those actions in the action section. You will have all those four operations for mentioned for our LR parsing, that is shift, reduce, accept and error. So all this S stands for shift, all these R's stand for reduction operation. Now you have accept. Here only one cell will have the accept, and all these blank cells are errors. Obviously they are all errors. That means if you take an example, suppose on state 1, if you are getting a terminal symbol A in the input, that means it is an error. So that which makes that input string an invalid one. So like that, these are the action operations. Actually, action section mention the operations which are mentioned for a particular LR parser. Okay, so let us consider an input string A B B B. So this is an input string that needs to be checked across this particular grammar. So you need to do a parsing for this particular string. So we will have step-by-step procedure for this. You need to see the stack, and you need to see the input buffer, and what action will be performed on those items that you are on those symbols that you are going to check. So as a first step, it will be on the stack, it will be the state 0. So 0 is the initial state. So initially you will populate the stack with the 0 as the top of the stack. So dollar will be marking the bottom of the stack, and 0 is initially 0. The initial state of this DFA will be the top of the stack. And input you have the same string A B B B, and for right hand marking you have the dollar symbol. Okay, so parallelly let us also consider constructing the parse tree bottom up here. So you have mentioned here that is A B B B. So that is the input string is being mentioned here. So let us try to construct the parse tree bottom up as and when you go here in this tracing step by step. So what is the action that need to be performed if you have such a thing in the stack and you have input? So input means you are going from left to right. So the scanning will be done from left to right as usual. So you need to consider this top of the stack as well as the current input. So current input is the leftmost terminal, and on top of the stack here it is 0. So you need to check in the parsing table on 0, the state 0 on input A, what to do. That action has to be taken from here. So 0 on input A, you have to do a shift operation to 2. So that is what as action you need to do. So 0 on A, you need to do a shift operation, that is S2. So it is shift 2. So that is a shift 2 operation. So what do you mean by a shift operation? So if you recollect, shifting operation is the action. If the action is a shift operation, you need to push 2 to the stack and advance the input pointer. So two things you need to do when there is a shift operation. You have to push the state 2 onto the stack, and so that the 2 will be the new top of the stack, and you have to advance the input pointer from to the next input terminal. Okay, so that we will see here. So 2 is pushed and input is advanced. So input advanced means you will be for the sake of seeing it, you will be just removing this symbol from here. So this is the right now 2 is at the top, and you have at the input you have A, B, B, B. Okay, so now again the same thing on 2, 2 as the top of the stack, 2 on A, what to do? That will be, you will be taking from here. So 2 on A, it is again a shift operation to state 2. So that is mentioned here, shift 2. So shift 2 means again 2 has to be once again pushed, and you have to advance the input symbol. So that is 0, 2. 2 is pushed here in this step, and input is again advanced to the next terminal. Okay, now 2 on B. 2 on B, it is a shift operation. The state is 3 here, so it is shift 3. 2 on B, it is shift 3. So that is done. So on shift 3, what to do? 3 will be pushed onto the stack and input. Since it is a shift operation, you have to advance the pointer to the next terminal in the input. So 3 is pushed and it is advanced to the next symbol, that is B. Okay, now 3 on B, 3 on terminal B, it is a reduction operation. So now here one thing that needs to be noticed is here at this when the input pointer reaches this, you have to do a reduction operation. That means reduction is done only when you have already seen the sequence of symbols. Actually here okay, can you just imagine what will be the handle here? The handle will be the just previous symbol that you have seen. Or when you are doing a reduction operation means you have already seen the sequence of terminals which could be reduced using a particular production. So here you have already seen B, so this B will be reduced to the left hand side of the, so B can be reduced to left hand side non-terminal. So that is which is going to happen here. So reducing using 2 means you are reducing using this production, so that will be mentioned here. So basically reduction happens for just previous terminal, that is it is not this B which is getting reduced, but it is the B which it has already seen which is getting reduced. So it is reduce S gives B. Okay, now we need to see those steps. When you do a reduction operation, there is another step that you need to do, that we have already seen that. So you have to see how many symbols are there on the right side. Okay, before that let us mark that in the parse tree also. So you are doing the first B is getting reduced to S. So in the parse tree let us mark that. Okay, so this is the B which is getting reduced to S. So let us mark it. So it is getting constructed. So we will be constructing the parse tree from bottom up. Okay, so here let us come to this point where you have this production for reduction. Okay, so let us check how many symbols are there on the right hand side. There is only one symbol. Okay, so you have to take the length of those symbols. So how many symbols are there? Those many states has to be popped off the stack. Okay, so here we have only one symbol. So one state from the stack has to be popped off. So that is 3 has to be popped off. So the number of there will be a popping of states which happens whenever you do a reduction operation. So how many popping has to be done? That depends on the length of the right hand side of the production that you use for reduction. Okay, so here it is 1, so 1 state has to be popped off, that is 3 has to be popped, and once 3 is popped, the new top will be 2. So on 2 you use this non-terminal. So on state 2 when S transition will take you to the state 4. Okay, so I'll repeat. So you will be popping the number of, you have to count the number of symbols on the right hand side. Those many states has to be popped off. So here it is 1. So 3 will be, only one state will be popped off, and the new top will be 2. So 2 on the left hand side. So 2 on yes will give you 4. That is 2. You have to go to the parsing table. 2 on yes gives you 4. So that is the new state that has to be pushed. So now 3 is popped off. That means 0, 2, 2, and 2 on yes gives you 4. So that 4 has to be pushed onto the stack. So it will be 0, 2, 2, 4. Okay. So 0, 2, 2, 4, and the input doesn't have any change. So this is the whenever you do a reduction operation, these are the things that needs to be taken care. So now again the same thing, 4 on, now the new top is 4, so 4 on B, you have to check it here, 4 on B, it is a shift operation to the state 5. So it is shift 5 here. That means shift, what do you mean by shift? This 5 will be pushed onto the stack and the input will be advanced to the next input token. So that is 5 is pushed and you have input advanced. So this is B here. Now 5 on B, 5 on B, you have R1. You have R1. So here again reduction operation using the first production, that is 1, S gives ASB. So what does it mean? Here you are otherwise telling that you have already seen ASB on the input. That is why you are going to reduce it to S. So just now whatever you have seen is ASB. That is what it means. So here if you check in the parse tree also, this A, now you are at the, actually if you see here, you are at the last B, that is here. So that means you have just previously you have seen A, S and B. So that is this A, this S and this B is being reduced to S. That is what it is happening. So we will see in the parse tree that, see, A, S and B will be reduced to S. Okay. So that is what which is happening here. Now how many symbols are there on the right side? 3. So 3 states has to be popped off this, that is 5, 4 and 2 has to be popped off, 5, 4 and 2, and after removing it, now the new top will be 2. So 2 on the left hand side, that is 2 on S, again it is 4. So now after popping 5, 4 and 2, you need to push this 4 onto this stack, that is 0, 2 and 4. Okay, now you have to check again the same thing, 4 on B, 4 on B, it is a shift operation that you already know. So shift operation, 5 has to be pushed and input has to be advanced. So that makes it 0, 2, 4, 5, and here it is dollar. Now 5 on dollar, 5 on dollar, it is R1. So that means the same thing, reduction using. So what does it mean? Actually dollar comes on the right side of this last B, so it means it already have seen ASB. Once again it already has seen a handle, that is ASB. So you have to reduce using R1. That means ASB is already seen. So this A, S and B makes it again S. Okay, so we'll just see that. So see, it have reached this A, this S and this B makes it reduced to yes. So this is the parse tree. So parse tree is complete now. Now here if you see these on the right hand side you have 3 symbols. So those 3 symbols has to be popped off, that is 5, 4 and 2 in that order has to be removed. And what is the action that needs to be performed now here? So once you remove 5, 4 and 2, now you have 0 on top, 0 on yes, 0 on yes, you have 1. So that is this. So 1 has to be pushed. So now we will have 0 and 1 on the stack. So 1 on dollar. Now you have to check 1 on dollar. 1 on dollar, it is accept. So that is accept. So which is making it this AABBB to be accepted using this grammar. So our parsing is complete. You have traced out this has to be a valid string for this particular grammar. So you have constructed the parse tree also. This is the bottom to up construction of the parse tree. So this is how you do it.